there's optical interpretations, there's ways of looking at it, people starting from presuppositions, yada yada. But when it comes to physics, we don't have biases. We just display matter's behaviour in certain conditions so that when some other man makes a claim about reality and matter's behaviour, we should be able to witness it. If that's not what we're witnessing, then I'm afraid your interpretation is wrong.
Your base premise that says that motion is what gives you weight. So that means the Earth is moving at a constant speed and that's giving you weight. I want you to show me that.
No. There's another factor that you keep omitting from that, Jason. And
which is what? Inertia? Inertia, which means that the force would be coming from the resistance to the constant speed?
Yes.
Okay. So there is a resistance that you're going through. So the force is actually the resistance.
That would be true, Jason. There would be the vector force, the thing that's moving, i.e. the Earth reference frame, and then that other factor, which is a mystery, that causes what we call resistance or inertia. So it means any vector, resistance is there. It means any vector, resistance is there. If you want to use mathematical terms, I would say it's scalar.
If inertia is not intrinsic to matter, and it is a scalar quantity, not only does it have to be a magical fairy tale resistance that will decelerate all states of matter of various mass simultaneously without displacement, it also has to do it in every vector.
We're now ready to do this experiment, and I want you to watch the vertical motion of both these balls and compare them as they fall. There you see the motion of the two balls, one projected horizontally, the other dropping from rest, and both starting to drop at the same time. Now, in order to see the details of these motions and to compare them, let's watch them in slow motion. If we look at the horizontal motion of the ball I projected and construct vertical lines tangent to this in each one of our still shots, we see that these vertical lines are equally spaced. This shows that the horizontal motion of the projectile was one of constant speed, unaffected by the vertical downward pull of the Earth. Our general conclusion is then that the vertical accelerated motion of a freely falling body is unaffected by what goes on horizontally, and the uniform horizontal motion of a projected body does not depend at all on the fact that it simultaneously undergoes vertical acceleration.
The reason why we have to constantly accelerate to recreate buoyancy is because we're connected to the Earth, which is already in constant motion. And in order to overcome constant motion, you need constant acceleration.
The reason why you need to accelerate the item is because acceleration is the only way you can cause displacement. Period. There is not a single example or demonstration showing constant motion creating displacement. And there never will be. That is because it is impossible. So, what is the basis for claiming as constant motion causes displacement in the first place? There is no reasoning or justification whatsoever. You do not overcome the reference frame. You add to it. The reference frame, as Schilliam describes it, is just a linear motion, nothing more. We can call it the primary motion. And by adding secondary motions of a known direction and velocity, you can calculate and determine things about that primary motion. Let's use this simple illustration to explain what I mean. If we start with an object here in position A, and it moves in a straight line at a constant rate to position B, it is simply moved from A to B. As far as the object is concerned, it is exactly the same as if we rotate it 90 degrees like this. It is still just moving in a straight line from A to B. The object doesn't care about its orientation. Looking at this primary vertical motion from our example, we see that the red line denotes the vector or direction of travel. If we take that primary motion and simultaneously add the second lateral perpendicular motion to it, we get this. Neither the initial primary motion, nor the additional secondary motion are superior. They simply combine to create a new vector or direction of travel. The object does not care if the vector is created from a single motion, or a combination of two motions. Once again, it is simply traveling from A to B. In this example, the vertical and horizontal motions are both at the same velocity. So the new vector will be at 45 degrees relative to them. The plumb bob shows us the direction of travel. If it is to be believed that vertical constant motion affects the plumb bob, then horizontal constant motion must also affect the plumb bob. You cannot have it only work in one direction. But it doesn't matter how fast you travel horizontally. If the velocity is constant, the plumb bob will always hang down vertically in its original position. This definitively proves that constant motion is not the cause of the vector. However, if you accelerate at constant rate horizontally, the plumb bob will show the new vector. And if you accelerate horizontally at 9.8 meters per second squared, the plumb bob will hang fixed at 45 degrees. This absolutely proves Newtonian physics correct, and it proves that the Earth must be accelerating. Hang a plumb bob from your car rear view mirror next time you go for a drive and try it for yourself. You cannot argue with this.